Okay, let's look at this example. In a balanced three-phase system, the ABC phase, ABC, that means positive phase, sequence is delta connected. So your source is a delta source with the voltage VAB equals 120 angle 30 RMS. The load consists of two, not just one, two balanced Y's. So we have two Y loads. So this is what we have. We have, this is A, this is B, plus to minus VAB, that's your source, is 120 angle 30. This is VBC, which is 120 angle, subtract 120 from that one, which will make it negative 90. And this is VCA, which is 120, subtract another 120 from this, that will make it what, 220? That's what your source is. You're trying to attach this to a Y load, so we have two of them. The first one is 10 plus 1J. So this is A, B, C. This is N, 10 plus 1J, 10, 1J, 10, 1J. You also have another one that looks like this. And this is what? 20 plus 5J. So if you attach A to A to A, and B to B to B, it's not going to be a pretty picture. So it might be easier if I take this source here and change it to Y source. If you change it to Y, it will look something like this. C, B, A, and this is N. And VAN, you're always going to take VAB, because you were given VAB right there. You divide it by the square root of 3, always, and you subtract 30 degrees from it. 30 minus 30. So what is 120 divided by the square root of 3? It's roughly 69.3 angle 0. So this one will be 69.3 angle negative 120. And this will be 69.3 angle negative 240. And if you attach this A to that A, and the ends together, and you look at one of them, what you're going to see actually when you look at that, a circuit that looks like this. This is VAN. Attached in parallel with 10 and 1J, 20 and 5J. Now I can use my calculator to convert these values for me. I can switch them to phasor and do the product over the sum. That'll be a quick way. We know at VAN this is 69.3 angle 0. So if I do that, this is what I have. 69.3 angle 0. And this one, let's see what that value is once I go to my calculator. clear. Here we go. Parentheses. I'm just going to write 10 plus 1j, or 1i. Where's the I? Oh, here we go. Close parentheses. Oh, I'm in actual rectangular mode. I gotta switch it to polar. Boy, it's been a while since I used this one. Rectangular to polar. Oh, nope, not this one. Escape. Where is it? Oh, come on. Polar. Oh, here we go. One more. Oh, spherical. Second. 10 plus 1j. I don't know where on the calculator. Just gotta. I can't see where I'm sitting here. You do the product over the sum. Now, what you're looking for is the current from A to A. Well, if I know, let me call this one I sub 1, and let me call this I sub 2. So I sub 1 is going to equal to what? 69.3 angle 0 divided by 10 plus 1j. And I sub 2 is going to be what? 69.3 angle 0 divided by 20 plus 5j. And I sub AA, once you have these answers, I sub 1 plus I sub 2, which is, here's what I got. The first one I came up with 6.89 angle negative 5.71, and this one I got 3.36 angle negative 14.04. So when you add them here, you add these two numbers, I came up with 10.23 angle negative 8.7 degrees roughly. And this is RMS, because the values were RMS. Once I know I sub AA, can I find I sub BB? Again, subtract 120 from that. Negative 128.7. I think that's a 5, not a 7, but 7.5. I can't really see in the dark. I think that's a 5. My eyes are not the best. And I sub CC, subtract another 120 from that, or so negative 120, that's 248.5 degrees, or 10.23 angle 111.5 degrees. So we found the current it says find the load phase voltage. Well, the load phase voltage, this is the load. What's the voltage here? That's VAN. This is N here. This is capital N. So the load phase voltage is right there. That voltage here, which is in parallel with this, so it's 69.3. And what do you think for B here? It's going to be this number. And for C is going to be that number. So that's this problem.